The borrowed materials like stories, songs, videos, pictures, brand names, trademarks, and other used in this material for educational purposes are owned by their respective copyright holders. Credit goes to their original owners. The author does not represent nor claim any ownership over them. The author has exhausted all possible means to ensure compliance to copyright management, and any content that does not go with the same is purely unintentional. Again, this material is solely for educational purposes only and not for business.
Hi everyone, and today you will witness our special segment entitled Amazing with Teacher Da.
Hey students, do you know what is our topic for today? Yes, tama ka dun. It's all about waves.
Thank you very much, Mr. Purest Energy, for that wave amazing dance performance. You heard it right. It's all about waves, and that is our topic. Would you like to know more about waves?
Yeah!
Okay, so we will proceed. But today, we will have a very interesting guest. Okay? So, by the way, welcome to my studio. An amazing morning to our viewers, and like what I've said a while ago, we will have our interesting guests for today. Not just one, but two of them. And they will share about our topic for today. Ladies and gentlemen, our guests for today, the Wave Twins, Transby and Longby. Thank you very much, Longby and Transby, and welcome to the show. So, would you like to say hi to our viewers? Okay. Again, thank you so much. And right at this moment, we would like to know more about the two of you, because like what our viewers said, they are not well familiar. Actually, because we are very limited when it comes to know more about waves. So may I ask our viewers, do you have any idea what waves are? Okay? Or you can give me an example. Very good. That's right. So, like waves in the ocean, like waving your hands, and ripples in the water are some examples of a wave. Okay? You can do it at home and you can try it. Just get a pail of water, or you can get at least a cup of water and then dip your finger up and down in the water, and then you will observe the wave. And that's what you call the wave train. Okay? And not only that, this will make a wave a disturbance, where energy is transferred from one to another. Making a wave a disturbance. Energy is transferred from your finger going to the still water. So, may we know how the two of you differ from one to another? Although you two are both twins and most the same. As you can see, will you please tell us or educate us, even our viewers right now, how the two of you differ from one to another?
Hi, I'm Longby, the longitudinal wave. I move left and right. I have rarefaction and compression. I need medium to travel. Sound wave is my example.
Right.
Hey, I'm transv, the transverse wave. I move up and down. I have crest, trough, amplitude, and wavelength. Can travel through a vacuum. Light wave is my example.
Thank you so much for letting us to interview the both of you. It is really indeed a pleasure for us for having the both of you here in our studio. Thank you very much, Longvi and Transv. Okay, so at this point, we will know your understanding about our topic for today. So I will do and we will do this activity for us to know and to understand this topic about waves. Are you ready?
Yeah!
Okay, it seems that you are ready. Now I want you to grab your slinky, your pen, and your paper, and then write all these questions and answer these questions. But first, you need to watch the activity that I will show you. Okay? In a count of 3, 2, and 1, let's start! Hello there, class, and for this activity, all you need to have is a slinky. This is what a slinky looks like. But in our school, in our laboratory room, the slinky that we have is a metal one. This one is just a toy. Okay? So before we start, all you have to do is to become observant. And please jot down all the observations that you will see. Okay? So, let us have the first activity. By the way, you can also try this at home, class. If you have a slinky, so if you have a spring-like toy, you can also use that. So, I want you to look at this one. Okay, can you tell me what type of wave is this wave? Okay, very good. That is a transverse wave. I have a very bright class. Very good. And the second one, I want you to look at this one, okay? Okay, now please tell me what type of wave is this one? Very good. That is a longitudinal wave. It seems that you already listened to our guests a while ago, huh? And it seems that you understood how transverse wave and longitudinal wave differs from one to another.
And there are different types of waves that we are going to discuss in this topic. So number one, the longitudinal wave. And this type of wave is based on its motion or how the energy is being carried. Okay, so in the longitudinal wave, source moves left and right, and coils move left and right too. So as you can see, ito yun. The wave moves left and right. So it goes also with the energy. And the other one is the transverse wave. So in the transverse wave, the source moves up and down, and coils move up and down too. See? So it moves up and down as the energy is being transported. This one, the particle motion is left and right, that is longitudinal, while in transverse, that is up and down. So maybe you can illustrate this one like the movement of a snake, di ba, a letter S. Parang doon natin siya pwede i-compare. So the subsequent direction of motion of individual particles of a medium is the same as the direction of vibration of the source of the disturbance or motion. Next, let us dissect a wave. So I have here an example of a wave and its different parts. So we have the origin, we have the amplitude, we have the wavelength, we have the crest, we have the another amplitude, upper amplitude, and then lower amplitude. We have the trough, okay? And then we have another wavelength, the lower wavelength. So let us discuss each part. So in the parts, the different parts of the wave consist of crest, which is the highest point of a wave. And this is the highest point of a wave. And that is the crest. Next one, we have trough, which is the lowest point of a wave. Can be found here. And then we have line of origin, meaning to say where it started, kung saan siya nagsimula. Signifies the original position of the medium. And then we have wavelength. Wavelength is the distance between two consecutive crests. So this is a crest, this is a crest, and then the distance between them is the wavelength. Even on the other side of it, between two troughs, okay, at the downside. And then we have amplitude. Amplitude is the distance from the line of origin to the crest or trough of a wave. So ito yun. Okay, this is amplitude, this is amplitude. Okay, so those are the different parts of a wave. So all you have to do is to remember the following things. Number one, a wave is a disturbance in a medium that moves from one phase to another. Number two, a wave transfers energy without transferring the matter. Number three, there are two kinds of waves. We have electromagnetic waves and mechanical waves. Electromagnetic waves do not require any medium of propagation. It can travel through a vacuum, katulad ng sunlight. Okay. And then mechanical waves require a medium for propagation like solid, liquid, or gas. So under mechanical waves, we have the longitudinal and transverse waves, or sometimes it is called the surface waves. Number five, transverse waves are waves in which each particle moves perpendicular to the direction of the wave motion, while longitudinal waves are waves in which the particles of the medium move parallel to the propagation of the wave motion as well. And also, surface waves have characteristics of both transverse and longitudinal waves. For number six, the characteristics of a wave are, we have letter A, period, that is expressed or written in symbol with the big letter T. Wavelength, that is written in a symbol for the inverted Y. Then frequency, that is written in small letter F. Wave speed for V. And then amplitude for letter A. And for number seven, wave speed is equal to the product of wavelength and its frequency. Then sound is a longitudinal wave that is produced by vibrating body in a medium. Number nine, sound is transmitted through material medium like solid, liquid, or gas. It cannot travel through a vacuum. It travels fastest in solid and slowest in gas or gases. So that is why when you are in the outer space, because outer space is a big vacuum, you cannot hear any sound there. But electromagnetic wave, such as sunlight, can travel through a vacuum. Kaya, dito pa rin sa Earth, nararamdaman natin yung sunlight. It's because electromagnetic wave can travel through a vacuum.
Thank you so much. I hope you learned something for today. So this is your teacher Daryl Del Mundo, leaving to you these words. Learning science is the key to abundance. Once again, an amazing morning with Teacher Da. Bye! Have a nice day, class!